Okay. First thing is, oh, that's not what I want. All right, I'm going to classwork. And we're on number 3. Oh. So let's move this over. All right, so today we are going to level 3. And level 3, where the tiny wild things are. So we are going to look at arachidibacteria.
There she is.
And
Beautiful Miss Miracle.
oh, thank you.
Came back from Boys and Girls. I don't know.
Okay,
What's wrong
wonderful.
with them or why it's wrong with them.
Thank you. So, this bacteria is some of the oldest bacteria, and it is believed, by the way, that they got incorporated in our bodies. And if you remember when we studied the cell, that mitochondria are believed to be this type of bacteria that give us our energy. All right, so, this one's tricky, it says, not good. So the first question, all of the species are arachnia. What makes arachnia bacteria different? Well, it's ancient, but let's go see. So where's our right here? Let's play. And where are you? Right here. Right here. Let's play on the big screen. All right. So this one is called One Fish, Two Fish, Red Fish, Blue Fish. Which was my favorite nighttime book when I was 2 years old. I had my mother read it to me every night until I memorized it and I could read it myself. All right, so we have the fishies here again. Clylid, I can't pronounce these things. A coelacanth, a shark, and a lungfish with a frog. So we have our magnifying glass. I've got to move this down a little so we can now look at the explanation of each of these. Hello. All right, so we have a frog. And we've seen this frog before. So I think the frog goes on a higher order, so it is at the top of the chart. Then we have our different fishies. If we look at the DNA,
Wait, wasn't this one the March 26th one or the one due today?
This is the one due today.
Oh, so you didn't post it yet?
Right.
Oh, okay.
Oh, I did post the first part.
Oh, okay.
So this is second half. So if we look at the chain of events, the lungfish, the coelacanth, and the frog have almost the same DNA here. And then the shark and the clylid are totally different. So scientists originally believed that the coelacanths were the closest relatives, but later found out their DNA was a little different. Do you remember watching Jurassic Park.
Yeah.
And what animal here did they use to make dinosaurs? Whose DNA?
It had to be the sharks.
No, it was a frog.
They used a frog.
Yeah, they used a frog. And the frog is close to us too. So looking at the genes that are present, only four-footed animals like the lungfish are more genetically similar to a frog. Okay, so let's see. Here's our goldfish again. With the bulbous head.
Mhm.
Oh, and the coelacanth, the ugliest fish. Again, they thought it was extinct, but it popped back up. The shark, who has been around for millions of years. Here is that lungfish. It sort of looks like an eel.
Yeah.
But they can live on land as well as water. That would scare me half to death. All right, so let us see if we can build this. So, since the coelacanth is the oldest, I would put it first. But if I look at the DNA, frog, coelacanth, lungfish. Well, this is just a let's go this way. Frog, Clylid, the goldfish, and the lungfish. What do we got? 2, and then the great white shark. Okay, so 1, 2, 4. So yeah. 1, 2, 3. All right, so so I am going to take this 1, 2, no, yeah, 2, 3, no, I want this. All right, 3. What do I want to do? I want to do 4, 5. All right, let's try this. So I want to put my DNA up there. So A position 10. A position 10 is the frog and the lungfish. So that goes there. C position 3. 1. This is position 3. So C position 3 is everybody but the shark. So I'm going to put that there. Position 4 happens to be everybody. And T position 1. So that is the 3 of them. So I'm going to put it there. All right, so A position 10, T position 1, T position 3, and T position 4. Oh, what am I missing? I messed up something. How did I mess this up? Oh, hold on. I see. Position 3, position 4. Let's see if that does it. Yay! All right. So, in 2013, scientists found that coelacanths are not the closest relative. Which animal is? It's the lungfish. All right. So now we can go to the next. Now, but before we go, let us answer this question. So the difference is the ancient bacteria thrives in extreme conditions, which so extreme conditions include high, oh, sorry, I didn't mean to do that. Hot springs, volcano vents, sulfur beds, methane gas. Okay, that answers that. Which 3 organisms all have the same position? So it was the lungfish, the coelacanth, COALACANTHE, and the frog. Okay, so we had the shark, the goldfish, which is called a cichlid, and CANT, oh, no E at the end. The coelacanth. Oh, okay. You spell it right. Control C. All right. Now let's move down. Oh, so that's we're done with this. But now let's move on to our last. So I have filled out, not that one, this one. This we have answered, and here are those 3 answers for you guys watching the video. Pause it and copy it. And let us finish our game. All right, so now we have some actual tiny wild things, some actual bacteria. So these are Thermophilus, which means it lives in extremely hot environments. Sulfatacus is in sulfur environments. So here you go. So this is commonly found, this goes with our answer, extreme environments, hot springs, thermal vents, pretty colors. So they like to look at toasty temperatures between 150 and 170. They are remarkably heat resistant, and they're used in biotechnology. That's exciting. All right, so the next one, we'll come back to this. All right, so this is the Vinicum. People breathe in oxygen, and when we breathe out carbon dioxide. But this bacteria takes in light and hydrogen sulfide, which sulfide, smells like rotten eggs. And so it produces little tiny clumps of sulfur when it is its waste product. I guess they live in lakes and hot springs. All right, so this one, Diurus radiodurano, this is the ultimate survivor. It can withstand 3,000 times more radiation than humans and lives in extreme cold with little water and acid. I wonder where that is. It has an ability to protect its DNA and repairing it from damage. This is an ancient bacteria, because you got to remember what the original environment of the world was. You know, it was volcanic, bubbling acids everywhere. So this thing has had to survive for millions of years. All right, so this type of Acnea bacteria is called a methogen. because it can produce methane gas. All right, as a waste product. It's put in sewage treatment plants, oil wells, soil, and sediment. I guess it eats up the fecal material. And here we have pyrobacterium. It can respire not just oxygen, but also nitrogen and sulfur, and even some metals. And it likes to live at 200 degrees. Oh my God. You know, a bath is about 100. And so it's classified as a hyper. Remember, hyper means great. Thermophile. So thermo, hot. All right. Is this back? Oh, this is also a thermophile that lives in volcanic hot springs, and it produces sulfur. I've seen this at Yellowstone National Park with the hot springs. Let's see if I can find that's why it's called Yellowstone. Images. You see the the yellow rings are from these type of bacteria. All right, now we're at the beginning. All right. All right, so now we have to look at the DNA and start putting it together. So I'm going to make this guy the first one, even though the trick to these, by the way, is looking at how many matches. It goes in order from 1 to whatever. Okay, so those both have 3. You know, I'm doing 2 of these at once. Oh, that one's 3 also. So let's get it all together. Are they all 3? Nope, that's a 2er. So let's put this guy over there. Here's the one I think is really old, but no, it's a 3er. Okay. And let's see where that's a 2er. So as you see, okay. All right, so C in position 7. We have 3. This one, Activans. This one and the Sophie. All right, so that goes there. C in position 8. We have a radiums. Is that a G or a C? And a thermophile. Okay, so that goes there. C in position 15. 1, 2. Aereo and Sophie. Well, these 2 go together. G in position 2. Oh, they're all G in position 2. So, and T in position 15. I've got 3. Thermophile, Vivi, uh-oh. Can I move one? Yay, I did it. Now we just have to replicate it over here for everybody. All right, those 2 are good. So then we're going to put this here and this here. What goes where? Oh no, this goes over there. This goes there. Mm-mm. 1, 2, 3. Now 1. All right, so 1, position 7. All right, position 15 is over here. And there we go. Yay. So, okay, let's see what our last question is. So we built the tree using DNA. Why was examining DNA better than the physical traits? So physical traits are hard to examine with such a small thing. Organisms that behave differently can be genetically similar. Certain traits evolve multiple times, which we saw multiple times. Like a lot of them were heat resistant. We had a few sulfur. I think it's all of the above. So let's see. Yes, all of the above. So, all right. Wonderful. Even tiny organisms that allow them to evolve in dramatic ways thrive in extreme conditions. So if the only thing you learn is to know that there is this group of bacteria that still exists on Earth in these extreme worlds. Okay. So I'm going to score this. I have completed mission 3. So